Array lists are like a flexible to-do list. But what if you need to organize data in a strict sequence, moving only forward? This is where singly linked lists come into play. Picture a train trip across several cities, each connected in a straight line. Just as you move from one city to the next in sequence, a singly linked list in programming advances from one station or node to the next in a specific order. If you and your friend are traveling on the same route, but his travel route terminates 3 stops before yours, then you would have to have different linked lists, unlike a train where you can travel by the same one till the cities match. This means that if you are storing the names of cities in a linked list, and if the sequence is different, then the linked list must be different. In this video, you'll explore the structure of singly linked lists, how they're manipulated, and how they're implemented in Java. First, a singly linked list is a data structure where elements are arranged in a linear sequence. But unlike arrays, they aren't stored in consecutive memory locations. In a linked list, memory allocation is done only when a new node is added, which could be anywhere in the memory available. The operating system will decide where memory is allocated, which could be in a non-continuous location from the previous node. This is why you need a link to point to the next or previous allocation to access that area's value in memory. Each node has 2 key components, data and next. Data is the value stored in the node, like a city's name. Next points to the following node, similar to the next city on your train route. The first node, called the head, acts as the entry point to the list. Each reference, pointer, or link connects one node to the next, except the last node, which points to null as a reference. This indicates that there are no more items in the linked list. The term null means undefined, and in the case of linked lists signifies the next node is undefined or unavailable. Similar to planning a train journey by connecting each city or landmark, working with a singly linked list involves declaring and linking each node, creating a path from one stop to the next. To begin your journey or list in Java, you must first define each stop by creating a node class. Each node stores essential information, such as the data, the name of the city, and a reference to the next stop. Once your nodes are defined, you need a way to manage your journey. This is where the linked list class comes in. It acts as the starting point, with the first station, the head, leading the way, and each stop linked to the next, guiding you to the end. To initialize a singly linked list, create an instance of the linked list class. When you create the linked list, it will initially be empty. Since it is empty, there are no references to point to, so you can set the head node to null using the this keyword. With your node and class set up, building a linked list is like planning a train journey across several cities. Your route is mapped out, but plans can change. You might add a city, skip a stop, or update a destination. A singly linked list lets you manage these adjustments seamlessly. Suppose you discover a city you must visit and want to add it to your journey. In a singly linked list, this is like adding a new node. For example, imagine a planned train route that goes from New York to Richmond and then directly to Washington. If you want to add Philadelphia to your journey, placing it after Richmond but before Washington, here's how it works. First, create a new node for Philadelphia. Next, adjust the links by connecting Richmond to Philadelphia instead of directly to Washington. Finally, link Philadelphia to Washington. Your journey now flows smoothly from New York to Richmond, adds a stop in Philadelphia, and continues to Washington without disrupting the other stops. In Java, adding a new node to a singly linked list involves updating the next reference of the preceding node to point to the new node, keeping the sequence intact while accommodating the change. If a stop no longer fits your travel plans, you can skip it. Suppose you decide to skip Philadelphia. You must remove the respective node from your linked list. Observe that Philadelphia is a part of the route because New York points to Philadelphia, which in turn points to Richmond. What if New York directly starts pointing to Richmond? Philadelphia will automatically be removed from the route. So, in a linked list, you identify the node to be removed and update its previous node's reference to point directly to the next node. The unwanted node is left out, keeping your journey smooth. So, instead of stopping in Philadelphia, you directly travel from New York to Richmond. With this adjustment, your train travels smoothly from New York to Richmond and continues to Washington. Removing Philadelphia simplifies your trip, allowing you to focus on the key destinations. This quick modification keeps your journey streamlined and aligned with your preferences. When you update the previous node's reference to remove a node from the singly linked list, remember that the removed node is no longer pointed to by any node. It means the removed node is dereferenced and cannot be accessed. If you want it back, you must create it again. But what if a stop changes? You visit a different part of the city or the destination name updates. In that case, you'll need to update the waypoints in your journey. In a linked list, this means simply updating the data in the corresponding node to reflect the change. Initially, your route starts in New York, stops at Richmond, and then heads to Washington. Remember, each city is a node, with data representing the city's name and next showing the link to the next city. To update it, locate the node containing Richmond and change its data to Philadelphia. Note that currently a node's data only contains city names, whereas in a real-life scenario, a node representing a city might contain detailed information such as city name, population, and coordinates. In such a case, the singly linked list behaves the same, except that the node now has more than one data point. Your journey adjusts accordingly. Now it starts in New York, stops at Philadelphia, and continues to Washington. This update demonstrates the flexibility of singly linked lists in managing dynamic data without needing to restructure the entire route. In this video, you've explored how linked lists work conceptually and in Java. A singly linked list is like a train journey, where each city is a node and the tracks between them connect you from one city to the next. The node of a singly linked list might contain data about anything, not just city names or detailed data points. This gives you the power to store a collection of objects together as a single entity, the singly linked list. This simple yet powerful structure enables efficient management of data sequences, whether you're handling a short list or a long chain of data. Just like a train journey where each stop is essential, every node in a singly linked list plays a crucial role in guiding you through your data efficiently and effectively.